नमः। हरि ओम। सहना भवतु सहनो भुनक्तु सह वीर्यङ्करभावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ओम शांति शांति शांति। हरि ओम। संग नो मित्रः सं वरुणः संग नो भवत्वर्यमा संग न इंद्रो बृहस्पतिः संग नो विष्णुरुक्रमः। नमो ब्रह्मदेव नमस्ते वायो त्वामेव प्रत्यक्षं ब्रह्मासि त्वामेव प्रत्यक्षं ब्रह्म वदिष्यामि हृदं वदिष्यामि सत्यं वदिष्यामि तन्मामवतु तद्भक्तारमवतु आवतु माम् आवतु भक्तारम्। ओम शांति शांति शांति। हरि ओम तत्सत्।
Good morning from India as well as to the globe also. Suprabhat, Suswagatam. This is the occasion when we are going to celebrate the Bikram Sarabhai Memorial Lecture Series on behalf of National Council of Researcher Teacher Scientist India and National Council of Student Scientist India previously affiliated to Vigyan Prasar, Department of Science and Technology, Government of India. And this event is also honored with the National Award for Science and Technology Communication from the National Council of Science and Technology Communication under the Department of Science and Technology, Government of India. Also, this is a time when India is going to celebrate its 78th in Republic Day, adoption of its constitution tomorrow on 26th January. And also, we already celebrated on 24th January the death anniversary of our renowned nuclear scientist as well as scientist who founded the space mission like activities in India, Dr. Professor Homeo Jahangir Bhabha. On this occasion, it's our privilege we are getting the opportunity to listen at such a person of that height from NASA, who him herself a renowned person, a renowned volcanologist. He served NASA for a decade, more than 2 decades, and also whose name is sufficient to introduce herself, being a senior research scientist at NASA JPL Jet Propulsion Laboratory, as well as who also serving as manager and deputy director, like senior most post for the for its planetary section. And not only that, she is the person for whom we got understand the knowledge of volcanoes and knowledge of the planetary science, very specially for Mars, Jupiter, and Saturn and its moon. So I would like to welcome our guest, most talented person, Dr.
Hello.
Rosal, Professor Dr. Rosaly Lopes. Basically, she is from Brazil, but now she is joining from NASA JPL Center. So it's our blessings, ma'am. Welcome you, ma'am. Thank you for joining us. It's a very much we are feeling very much honored that you joined us, because I think of a such height of your experience, your expertise. This is the first time we are organizing such a grand webinar with you and your like person, ma'am. So I think it will be a greater learning for our students and teachers, as well as scientists also, some scientists also joining, knowing that you are joining our event, doctor. So it's a privilege to you, and privilege for us also, that they are also joining. And it will be a grand learning session, as well as it will be helpful when we are taking oath to make our India as a Viksit Bharat, a new India in the age of the globalization, as well as global opportunities also. So welcome you, ma'am. Just I am introducing some points and facts, whatever your achievements is, and how your path was. It's our privilege that we have some information from JPL NASA Center also, as well as ma'am is also have a page on Wikipedia. So we just seeing this thing also.
Hello. It's my great
Yes,
privilege to
ma'am.
be
Yes.
here. Can you hear me?
Yes, ma'am. Sure, sure.
Okay. Thank you. It's my great privilege to be here, and I thank you very much for inviting me to speak to your students and your teachers. And as you said, my name is Rosaly Lopes, and I'm originally from Brazil. So in this talk, I will not be able to cover everything that I have researched or done, but I want to give a little flavor about my story um, from Rio de Janeiro in Brazil to the Jet Propulsion Laboratory in California. So I hope that we have some time for questions at the end. I am going to
Correct.
present. Share screen.
Ma'am, just some, ma'am, if you
Yes.
allow, I want to
Yes.
read some points of you about your life to introduce the students and teachers audience from Wikipedia and JPL also. Then
Okay.
we'll come to you again.
All right. Yeah, sure. Yes. Mm.
So this is the information bio note of Rosalie Lopes, senior research scientist, Planetary Science, NASA, JPL, Jet Propulsion Laboratory, and Rosalie Lopes, ma'am, is
Yes.
Directorate Scientist in Planetary Science Directorate and Senior Research Scientist at NASA's JPL, California Institute Technology. Dr. Lopes was born and raised in Rio, Brazil. She has a Bachelor Science in Astronomy and PhD in Planetary Science from University College London. Her major research interests are planetary and terrestrial geology and volcanology. As a volcanologist, ma'am has a renowned person in the field of volcanology also. And during her PhD, she traveled extensively to active volcanoes, particularly Mount Etna in Sicily, and become a member of UK's volcanic eruption surveillance team. Dr. Ropse joined JPL, Jet Propulsion Laboratory of NASA, as a National Research Council Fellow in 1989. In 1991, become a JPL employee and member of Galileo Flight Project, a mission to Jupiter. She has responsible for observation of Jupiter's volcanic moon Lo from 1996 to 2001 using Galileo's near infrared mapping spectrometer. During this exciting period of her career, she discovered 71 active volcanoes on Lo, that is the Jupiter's moon, uh, for which she was honored in the 2006 edition of the Guinness Book of World Records as a discoverer of the most active volcanoes anywhere. Lopes worked on the Cassini mission to Saturn from 2002 until 2018 with the role of investigation scientist for the Cassini Titan radar mapper team. She is currently studying data acquired by Cassini, in particular the geology and particular habitability of Saturn's largest moon, Titan, as a project investigator in NASA Astrobiology Institute, leading an international team. She has received many honors for her contributions to the studies of volcanism of on Earth and other planets also. In 2006, she has elected as a fellow of the American Association for the Advancement of Science, and in 2015 fellow of Geological Society of America. In 2018 she received the Ambassador Award and from American Geophysical Union, and become a fellow of that society and elected member of the International Academy of Astronautics. Other awards include two NASA Exceptional Public Service Medal 2007 and 2019, the Adler Planetarium's Women in Scientist Award 2018, an Antarctica Medal for the National Science Foundation, the Lower Thomas Medal, Lowell Thomas Medal from the Explorers Club 2014, the Wings Women of Discoverer Air and Space Award 2019, and so many awards. She was honored by the International Astronomical Union with asteroid Rosaly Lopes also. Dr. Lopes has taken many leadership role in the scientific community at the global platform. In addition to serving as vice chair of commissioning B of COSPER, she chairs the Outer Planet Task Group of the International Astronomical Union Group Working Group for the Planetary System Nomenclature, is a member of the Space Studies Board of the US National Academics and member of the steering committee of the SCAC Institute of Space Studies. She served as a elected chair of division for the planetary science of the American Astronomical Society 2012 to 2013 and president of American Geophysical Union's planetary science section. She was editor in chief for the planetary science journal Icarus from 2017 to 2020. Dr. Lopes has so many publications and peer review scientific publications and 8 books also. The Volcano Adventure Guide from Cambridge University Press, Volcanic World Exploring the Solar System Volcanoes from Springer, Low After Galileo from Springer, Alien Volcanoes from John Hopkins Press, and so many write-ups and books. The first planetary science book to have all its chapter written by female scientist also, he has been honored, and to have Arthur C. Clarke and James Cameron writes the foreword for this respective alien volcanoes and alien seas also. In addition, her science work, Dr. Lopes is a strong supporter of education, diversity, outreach, nationally and internationally. As you are also viewing that, she is helping us also with a short notice and breaking the all barriers of time zone. She has given numerous public lectures in US and abroad on every continent, including Antarctica also. She has been active in media, giving hundreds of interviews, and has been featured on over 20 TV documentaries and shows in the US alone, including National Geography, Discovery Channel, Science Channel PBS, and Weather Channel and History Channel also. During his academic period, she completed her PhD on Planetary Science, University College, University of London in 1986, UK, and BSc Honours in Astronomy, University College of University of London, UK in 1978. In her professional experience, he served so many posts throughout his service life in Jet Propulsion Laboratory, California Institute of Technology. He is serving as a senior research scientist, JPL, for Art and Space Science Division from 2019 to present. And apart from this, he is a editor in chief for Icarus, and so many as a managerial or investigating scientist. He served so many part of his life. Moreover, she has been honored with a special Wikipedia page also. Here we are displaying that one. So this is the sum of few information, few facts about our today's guest of honor from NASA JPL, Dr. Rosaly Lopes.
Thank you.
So we are welcoming Madam.
Okay, thank you so much. I am now very recently, I got a new position at the Jet Propulsion Laboratory, and I am in charge of what's called academic engagement, which includes student programs and postdoctoral programs. So,
Congratulations, ma'am.
yeah, thank you. And
We
I
hope
really like.
under your this leadership, India will be another sphere of knowledge, gathering knowledge about volcanoes, about your experiences also, and
Thank you so
also
much.
get some inspire.
Thank
Thank you,
you.
ma'am. Please start.
Okay, I am going to. This is always difficult,
Yes, there is a
to
plus. Say,
yes, and
huh,
then do I
present.
share my screen or share slides?
I think
Uh,
sharing slide will be better.
okay,
Please open the slide
oh,
and then click the
uh,
slide, or you can
okay.
share the screen also.
Um, it says I have no slides, but I think I have to put it in
First, ma'am, you
presentation
open
mode.
the slide and then
Yes. Can you see it?
no, it is not shared.
Okay.
Try
So,
again, ma'am.
all right. Let me try again. Let me try to share my screen. Uh, share screen. Allow to share screen. Uh, share this window. Do you see slides now?
No,
Mm-mm. Uh, it should be. Maybe it's coming because. Let me try. Can you see it now? Oh, continue to share. Okay. Can you see it?
no,
No.
not on the
Oh,
screen.
it should be working. Uh, because from my end, it.
Open.
Yeah,
I
and
think I think I think you click open the this PowerPoint and open the then next you click the sharing and you have to share you have to click share screen and then
yes.
entire screen. One option is there, entire screen, and
Okay.
then on entire screen you have to click and share will be.
Share. Yeah. Sharing is easier. Screen sharing works. Yeah, oh. Um. Okay. It seems to want me to use um, uh, Chrome. So if it doesn't work, I'll have to try to come in again using Chrome. Um, uh,
Ma'am, you just
yes,
click share screen first, then
yes,
one window will open, and after you are finding that Chrome tab na, it's after that Chrome tab there is a window, and then next is entire screen. You click on entire screen and then click the entire screen, the icon of the
I
entire
think
screen, and
I
share.
think the yeah I think the problem is that I'm using another browser. I'm not using Chrome, and I
Acha.
think it doesn't like that. But it's strange because it. Oh, it says my browser has blocked my screen. Uh, oh dear. Okay. Is it better if I go out and come back
Sure, ma'am. Sure.
in again?
Sure.
Says
There is
your browser has
a
blocked your screen. Click the screen icon in your address bar to allow access. Then reload the page. Let me try with Chrome. And I'm sorry. It's it sometimes it works really well. And so I am going to try to come in with okay. Yes. Okay, let me try now. Okay, can you see it now?
no, ma'am.
No. It
Ma'am, you better, ma'am. You just click the plus symbol, share
yeah, I did.
screen,
Yeah, I
and
did.
when it is coming na to Chrome tab, you just avoid the Chrome tab, and there is a written entire screen. You go to entire screen and click twice.
Oh, it looks like there is I see my window and I see the next to it the
Next to
display
it is
window.
entire screen.
Yeah.
You
Okay.
click the entire screen,
So, okay.
and
Share
one icon
screen.
will you there.
Yeah, share
One icon will
screen.
there where our picture will come. Click on this picture and then share
Entire screen.
entire screen. Then the icon.
The
Click on icon.
okay. Allow.
Click the icon, ma'am. After after clicking entire screen, click the icon.
Yeah. Um. Let's see. It appears to me that it says is sharing a window. So for me, it
Yeah.
says it's sharing.
After window, there is an entire screen, ma'am.
Uh, uh, okay, I did. Share screen. It gives me only one option. Set share screen. I go to entire screen.
And next, just below the entire screen, there is a logo. Click the
Uh,
logo.
my okay, share. Got it. Yeah, it just doesn't
I,
because it
I
even
have
tells
sent in
me
WhatsApp, ma'am.
stop sharing. And so it means I am sharing. Um, I am going to try something else. I'm going to try.
Ma'am, I have sent the image in WhatsApp also. Please check this.
Okay. Oh, you mean you sent it on WhatsApp?
Yeah.
Okay. Um, Yeah. Oh, that doesn't appear for me.
Correct, correct, correct.
Um, so let me try again. Uh, I have three options: Chrome tab, window, and entire screen. And I've been sharing the entire screen, but doesn't seem to work. I can try a window share, and it says to me StreamYard is sharing a window. So
Yes,
maybe
yes, yes. It is coming, ma'am.
oh, it's coming.
It
Oh,
is
good,
coming.
good. Ah,
Yes, yes,
yeah.
yes.
All right. So let me put it on presentation mode. And very sorry about this.
No, 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 ma'am. No, ma'am.
These things can be, sometimes they work really well, sometimes they don't. Uh, so, what we see here is a beautiful picture of Saturn and its rings taken by the Cassini mission. As you said in your introduction, I have worked on the Cassini mission. I also worked on the Galileo mission before that. And I have also worked on other missions, but these two were the biggest. They are what NASA calls flagship missions. They are very big, expensive missions with a lot of instruments, and they take many years to get to the outer solar system. And so you can make a lot of your career out of one mission. So, as you said, I am from Brazil, so I'm going to tell you a little bit about my journey. I was, grew up in Rio de Janeiro in a family that didn't have any scientists. And I grew up hearing about the Apollo program, and I really wanted to be an astronaut. So that's me. It's like 4 years old and 6 years old and 16 years old. I grew up right by the very famous beach called Ipanema Beach that you see underneath. And I had this dream of being an astronaut. But I also realized I was Brazilian, a girl, and it was going to be difficult to become an astronaut. Uh, but I decided that if I couldn't be an astronaut, I would become an astronomer. And instead of going into space myself, I would help NASA explore the solar system. So, a big source of inspiration for me was when I saw a newspaper article about this lady called Frances Northcott. She worked at the Johnson Space Center during the Apollo 13 mission. She was a mathematician, and she calculated trajectories to bring the Apollo capsules back. And her nickname is Poppy. And I saw here is a woman working in mission control, and it was very inspiring to me because I thought if she could do it, I could do it too. And I try to, give talks to students who come from, countries that maybe don't have a big space program. That's not the case of India. You have an amazing space program. Also to girls, because sometimes they don't think that they can become scientists. And for many years, I tried to find Ms. Northcott, but she had left the space program. And many years later, I managed to find her, and here she is. Visited the JPL in 2019. We have met several times since then. She was quite amazed that she inspired this Brazilian girl to work at NASA. And here I am with some Girl Scouts, and in the background is a photo of JPL, and with superimposed the moon and Venus. I think it is. Of course, this is fake. The pictures are real, but the montage is not. So I try to uh, inspire girls to also go into the space program and jobs in the aerospace industry and the STEM subjects. So I went to study in England. I could speak English. That was very good that my parents made me learn English. And I was accepted into University College London. That's the picture you see on the left. It looks like a Greek temple. And I got my degree there in astronomy. And then below is me working on my PhD in planetary science. I started going to volcanoes, and the picture above, I'm in Hawaii doing some field work. And then I got a job as I was finishing my PhD working at the Greenwich Observatory. And I was, among other things, I was running a big refractor telescope and just for education purposes. And so I would bring in students and the public to observe through the telescope. But I also carried on studying volcanoes. And here I am in Hawaii. Kilauea volcano in Hawaii is very active. It's very active at the moment. And you might have seen it in the news. There are many spectacular images. So here I am on an active lava flow. You can see these red parts are all active lava. It's over 1,000 degrees Celsius. But lava cools very quickly, and then it forms a crust that is a very good insulator. So you can be walking on top of a lava flow, but underneath it's still all molten. So you have to be careful. And here's a picture taken by a friend of mine of Kilauea volcano. And that was some years ago, but the activity is very similar now. So there's big, what we call lava fountains. This one's about 30 meters high. And they are very, very spectacular. What do we do at the Jet Propulsion Laboratory? We are managed by a university, the California Institute of Technology. That's one of the best universities in the world for technology and science. Um, and on the top here is a picture of our JPL campus, and it's located near the mountains, and it's a very beautiful place in Pasadena, California. And we have sent missions to every planet in the solar system. We are very well known by for our Mars rovers, but we also do many Earth observing missions. Last year, we launched a mission with India, with ISRO, that's called the NISA mission, is an Earth observing mission. I have not worked on it, but many of my colleagues have. Um, but let me start with the some of the missions I worked on. Here is a drawing, is not a real photograph of the Galileo spacecraft. It was launched from the space shuttle in 1989. So the shuttle, as you know, is no longer being used. But there was a time when they were trying to use the shuttle to launch spacecraft. Um, but we don't do that anymore. Galileo was a mission that went to Jupiter and explored Jupiter and its moons. The moons of Jupiter are very interesting. There are a lot of them, but the biggest moons, the four biggest moons, are what we call the Galilean satellites, and they're called Galilean satellites because they were discovered by Galileo when he first used his telescope. And this is my favorite moon. It's called Io. A lot of people get the name wrong because they think the I is an L, or sometimes they even call it 10, but it's called Io. And it's very, it has a lot, the surface that is very strange. It's full of yellows and reds and blacks. And when the scientists on the Voyager mission back in 1979 first looked at Io, one of them said it looks like a pizza. And then it became known as a joke as the pizza moon. And why does it look like a pizza? Why does it have all these yellows and reds? Well, those are the colors of sulfur. If you have ever, handled samples of sulfur in a laboratory or seen in a museum, sulfur can be yellow, sulfur can be reddish. So these are different colors of sulfur. Io has a lot of sulfur dioxide on its surface. And the really dark parts, I'm trying to use my mouse. I don't know if you can see it, but the black parts are volcanoes where the lava is active and is dark. And one of the fascinating things about Io is that it has these plumes. Here are two of the plumes, one called Pilan and the other Prometheus. And these plumes can go up to 500 kilometers above the surface of Io. And they go so high because Io has no atmosphere, only has a very, very, very thin atmosphere. So this material that comes out of the volcanoes is expanding in a vacuum. So that's, it can go really tall. These are images from the camera on Galileo. But I worked with the near infrared mapping spectrometer. So I'm going to show you here. On the right is the infrared image, and this is at about 4.7 microns wavelength. On the left is in the visible. So all these bright points, that are shown here in white, in red, those are active volcanoes, and that's how I found these 71 volcanoes, active volcanoes on Io that we didn't know about before, because the Voyager, the first mission, only found about 12. And so we didn't even know if we were going to find any new ones. We were very surprised that we started finding so many. And I used to go through these images pixel by pixel and compare with the pixels around them to find sometimes, they're not very bright in the infrared. But so you really have to compare the pixels. Sometimes they're very obvious. So that's how I ended up in the Guinness Book of World Records, which started out as a bit of a joke, but someone knew a man who worked for the Guinness Book of World Records and told him, and that's how it started. But Io has many very interesting and beautiful volcanoes. This is about 70 kilometers across, this volcanic caldera, and what is black, dark, are the active parts, and the cool parts appear as yellows and oranges, and that's cool enough that the sulfur dioxide can condense on the surface. And sometimes it's difficult to imagine what is, you're seeing it, of course, from the spacecraft, what this would look like in real life if you were there. But I have an artist, a colleague, who started painting these volcanoes on Io as they would look if you were there. He's what's called a space artist. And here he painted his view of the interior of this caldera, and what this would look like if you could actually be there. So there is sulfur that is melting down from the walls and going covering the surface. The walls are quite steep. There is venting of gases. And so we collaborated on this image, and I liked it so much that I bought the original painting, and it's now at my house. And one thing that we found with Galileo studying volcanoes on Io is that many of them are lava lakes. So you have these calderas and you have lava lakes inside them. Now, what are lava lakes? Well, on Earth, we see several different types of volcanic activity. And some are like explosive, like here on the right-hand side at the top. This is a volcano called Yazur in the Vanuatu Islands near Australia. And these are small explosions, what's called strombolian activity. But there are some craters, volcanic craters, that have lakes of lava inside. It's just molten lava forming a lake. But these volcanoes are rare on Earth that have lava lakes. They are only, well, depending if they are active or not, there are like 5 or 6. And the one here on the left-hand side is Ambrem, also in Vanuatu. This was a few years ago because that lava lake is no longer active, unfortunately. It was just very beautiful to see. And it's about 100 meters down from where I am. We were getting some infrared measurements with an infrared camera. And another place where I went with my colleagues to find out about lava lakes was Ethiopia. Now, here's a region in Ethiopia. It's not a lava lake, but deposits of sulfur. This is similar to what Io surface might look like. And when we got to this lava lake, Ita Ali, here you're seeing just a piece of it, but is quite extraordinary. And I'm going to play a video here. And bear in mind that on the back here is the wall of the caldera. And then you have the lake, and the lake forming a crust that breaks up against the walls. So you see, it's like a sea or a real lake of lava. And you can also see how fast it cools, because when it goes dark, that is because the lava is cooling. And here it is in the infrared. So as I said, we took images in the infrared to look at the distribution of heat on this volcano and to compare with the lava lakes on Nile. And and we're standing right on the edge of it, and it's very, very hot. Sometimes we had to, you know, step back. Okay, so I also told you I worked on the Cassini mission, so let's change a little bit and talk about the Cassini mission. There are no, hot lava volcanoes on the Saturn system. Cassini went to Saturn. It took 7 years to get there. I didn't join the mission right from the beginning. Also, I didn't join the Galileo mission right from the beginning. I was brought in later, which is actually fun because then you don't have so long to wait. I joined Cassini in 2002. So we use this type of trajectory. This is VVEJ GA. That means Venus, Venus, Earth, Jupiter gravity assist. So this was discovered actually when Galileo mission was close to launch. That if you can use a planet's gravity to accelerate your spacecraft. If you do a maneuver that is called a slingshot maneuver, then you can gain energy, and your spacecraft can go faster. So without this type of trajectory, you would need a very, very big rocket or a very light spacecraft to be able to go directly from Earth to Saturn. So we use this long trajectory. It was a very international mission, which made it fun because it was a collaboration between NASA and the European Space Agency. And we arrived at Saturn in 2004. There's an image taken by the camera. And I worked with the radar, but we'll talk about that in a bit. And Saturn has seasons like the Earth. And when we arrived, it was summer in the Southern Hemisphere. So Southern Hemisphere is lit by the sun, and the northern polar regions are dark. So it's a bit like the Earth, that we have this long darkness at the poles, depending on the season. But we arrived in 2004, and our initial mission was only 4 years, but everything was working really well. So we asked NASA for more time, and they agreed. So we're able to observe the change of seasons. The equinox was in 2009, and then the northern polar regions came into view. Saturn is a gas planet, so a lot of storms in this gas planet. I don't study Saturn because I am a planetary geologist, so I want solid surfaces to study. So I study the moons, but there are many interesting things about Saturn and the storms, and colleagues of mine studied it. And also the rings are quite fantastic. And this is a real image. It's not artificial. And the camera on Cassini was able to uh, distinguish these many, many, many small rings. So the main groups are called A, B, and C, and it was known for hundreds of years that there was a gap in between two of the rings, and we used to think that that was completely empty. But the Cassini images showed us that, in fact, there are many faint rings inside that. Is called the Cassini division. It's not empty at all. And I'll show you my favorite image of Saturn and the rings. Mm, mm. So look carefully. The sun is illuminating Saturn and the rings from behind. And you see here that there are other rings further out. And this very gaseous outer ring, it's faint, is called the E ring. And it actually coincides with the orbit of Enceladus, one of the moons. But before we talk about that, you might be able to see a little, see, there is a little pale blue dot, and that's the Earth. That's the Earth seen from Saturn. So it's quite extraordinary that we could see the Earth. So this moon Enceladus, I said this faint ring, the E ring, coincides with Enceladus. Now that's a really interesting moon in terms of volcanism, because it actually erupts gases from the interiors. It's very strange. It's a very small moon, only 504 kilometers in diameter. We noticed these fractures in the ice. It's all covered in ice, and we noticed fractures near the south polar region. And then when the camera observed it, we saw this vapor. It's mostly water vapor, but they're like gases coming out from the interior. So this is a form of volcanism. It's not molten lava, but it's material coming from the interior to the surface. And that is the definition of volcanism. So that's just enhanced with artificial colors. So you can see these individual jets, and they are coming out of those fractures. And, what's happening? Well, there is actually a global ocean of liquid water under the ice crust on this moon. And that is in contact with the interior. And the Cassini observation showed that we flew pretty close to these plumes, and it showed that these plumes had some organic material like ammonia and methane. And so it made this moon very interesting to planetary scientists, because we have water, a lot of water. We have heat, so you have energy, and we have organic material. Well, those are three things that you need for life to start. We don't know what else is needed. No one quite knows yet how life began, even on Earth. But we know that life, as we know it, needs water, needs energy, and needs organic material, needs carbon materials. So NASA has a lot of interest in exploring this moon called Enceladus. And here, my colleague Michael Carroll made a painting of what it would look like, these plumes, if you were actually there. And so, because this artist and I had collaborated a lot, we wrote a proposal to the National Science Foundation here in the US. They control the facilities in Antarctica, and we applied and got accepted. So we went to Antarctica to write a book. Essentially, I went as the advisor scientist, he went as the artist, and we made a book where we imagine what kind of features we might have on Enceladus and Io and other places in the solar system. So this is on Mount Erebus, is a nice tower, and is formed by gases coming from the interior, and then they condense, turn to ice, and they form these towers. And to give you an idea of size, here I am near a couple of these ice towers. Mount Erebus in Antarctica is the only active volcano in Antarctica. It also has a lava lake, but I didn't. There were a lot of gases, so I couldn't get good pictures of it. But going back to Titan, to Saturn, so the moon I studied most was Titan. Titan has a very dense atmosphere. So this is an enhanced image. The colors are enhanced, but in the near infrared, and it shows it has this outer blue layer is an atmosphere, and it has the second densest atmosphere in the solar system. The first is Venus, the second is Titan, and the third is actually Earth. So it has a denser atmosphere than Earth. That is actually makes it good to land, because you can, with a dense atmosphere, it's easier to land, but it makes very difficult to see the surface, to see the geology. So we had a radar above on Cassini, and this is not to scale, it's just a drawing. But the radar can penetrate haze, atmosphere, cloud. On Earth, we use radar as well to study the surface of the Earth. This is synthetic aperture radar. And we found many surprising things on Titan, including this is a view of the North Polar region. And again, the colors are artificial, but you can see these dark blue parts are parts that are very smooth to the radar. And those are actually lakes and seas, but not of water, because Titan is so cold that water can only exist as ice. These are lakes and seas of methane. And here I show a comparison of one of the seas on Titan compared to Lake Superior in the United States. We call these features mare, which means sea in Latin. And the moon also has mare, Earth's moon, but they are seas of cold lava that erupted like 3 billion years ago. And Titan has seas of liquid methane. because at Titan temperatures, methane can be liquid. And just a curiosity, so we have Maori seas on Titan. We also have lakes, and the lakes on Titan are given names of lakes on Earth that have similar shape. And I'm sure there are some from India, and sorry, I don't have them in this picture. But these are some of the first that we asked the International Astronomical Union to name. Um, and a student was doing this work, looking on Google Earth images to find lakes with similar shapes to the lakes on Titan. Here you can see how similar they are. And I think she wanted to be nice to me, and she found one in Brazil, but she didn't know, and I didn't tell her that feia in Brazil means ugly in Portuguese. So we now have the ugly lake on Titan. So in the end, we actually had to destroy Cassini. And I'll talk in a couple of slides about why we had to do that. But how do you kill a spacecraft? Well, here's what we did. This is an animation. Oops, sorry. We modified the trajectory so that it started coming between the rings and Saturn. And because of the gravity of Saturn, each time we went by, we did several of these dives. And each time it got closer and closer until in 2017, it actually went inside the planet and was destroyed. And why did we have to do that? Why did we have to kill the spacecraft? Because we didn't have any more fuel. We're running very low on fuel, and if you don't have any more, you can't control it. So this death dive was because Enceladus and Titan are two places where life could exist, and if you just can't control the spacecraft anymore and you leave it around Saturn, there is a very small but still a probability that it could one day smash into Enceladus or Titan. And if there is life on either of these moons, we don't want it to be contaminated by, microbes and any life forms we might have brought from Earth. And in fact, after Cassini, I proposed a project to NASA that I'm still working on now, and that was to look at the habitability of hydrocarbon worlds like Titan. And so we analyze what organic materials we have in the atmosphere, and then they fall to the surface. They form a thick layer of organics on the surface. If they can get into the ocean, and we found they can, then they can feed biological activity. We had biologists on the project recreating Titan conditions in a chamber and finding that there are some bacteria on Earth that can survive it. So it's been a very interesting project. And I'm going to leave you. I would like some time for questions. I don't know how much time we have now. Sorry about the problems at the beginning. But this is another image taken by the camera of Saturn and its rings with the sun behind. And it's really beautiful. You can see the Earth in this image as well, but it's a little bit more difficult. So, I'm going to, show a piece of it. And I like very much what a famous astronomer who unfortunately is no longer with us. But what he said is to look at that dot that's here, it's home, it's us, and everyone you have ever known in the history of our species lived there on this little piece of dust suspended in a sunbeam. So, with that, I would like to open it up for questions. Should I stop sharing? Can you hear me?
Yes, ma'am, we are hearing.
Okay, all right. And
Thank you,
so,
ma'am, for a great lesson to us. For us, you have done a very nice thing presentation, and all the visuals are so attractive because we all are similar when it comes to the term space. The scenery of space, it really gives stimulates us to understand, to know, to listen, to hear, to observe all these things. And you have given this opportunity. So many persons are there, so many students are there who are willing to ask you, but we have some limitations of participants as well as time also. So we are taking one by one who are here. Please ask. First of all, from Lucknow, Arush Mishra.
okay.
Good morning, ma'am. My name is
You
Arash
can ask
Mishra
the
from,
question.
from Lucknow, and my question is during missions like Galileo and Cassini, what was the most difficult scientific uncertainty that could have only been solved when the spacecraft actually arrived at the position?
Well, there are always scientific, technological and scientific challenges. For example, uh, uh, Galileo. Galileo had a main antenna that didn't open, and we're not quite sure why that was, but we think it's because, you see, Galileo was supposed to go to launch earlier on a shuttle right after the Challenger. If you have heard about the Challenger disaster, uh, the shuttle exploded, killed the astronauts. It was very awful. Um, and then they stopped the shuttle program for 2 years. And so the spacecraft Galileo was already at Cape Kennedy, but he had to go back to JPL, and it goes by truck, and it had to be taken all the way there back to JPL, put in storage for 2 years, and that may have caused some problems. This antenna was one that opened like an umbrella, and it got stuck. It started to open, then got stuck. So we had a much smaller antenna, but the rate was very, very slow. So we had a lot of challenges, right? Because we only found that out after the spacecraft was already on its way. Um, and it was right, this was like in the, um, you know, uh, it was launched in 89, so in the very early 90s. um, we had to start thinking of things like, uh, uh, you know, data compression and lossless compression, and it was very new at that time. And even making the instruments more flexible, for example, with the spectrometer, instead of sending back 408 wavelengths, we could select just a few depending on what science we wanted to do. So that was a really big challenge for Galileo. And there always on Cassini, almost nothing went wrong. It was a really fortunate mission. But a big challenge on Cassini was to land the Huygens probe. It actually landed on Titan. I didn't have time to talk about that, but I said that with a very dense atmosphere, it's easier to land. But we didn't know on where we were going to land because we had not seen the surface. So, it could be, we could have landed on a hydrocarbon lake, we could have landed on top of a pointy rock. So the probe was transmitted data back as it was coming down, because we weren't sure we were going to live the landing, survive the landing. In fact, we did, but that was a big challenge, big unknown. Mm.
Thank you, ma'am. And you will be pleased to know that a group of students are viewing that one. This from Bundeleshwar. It's nearby Delhi, and their teachers and students are there. A group of students are listening you, sir.
Oh, thank
If
you.
you have, sir, if you have the question, sir, we are opened a astronomical club, and they are observing your lecture.
Good morning, ma'am and sir. First of all, good morning, ma'am and sir. First of all, thank you for giving me this opportunity to introduce myself. My name is Sipa. I am from village Malgaon, block Unchagam, district Bulandshahr, Uttar Pradesh, India. I am 13 years old. There are 6 members in my family. My father is a businessman. My mother is a housewife. I study UPS Malgaon. I am a student of class 7. My favorite subjects are science and English. My hobbies are reading and writing. My best friend name is Salini. I want to become a teacher. My favorite teacher is DK sir and Seema ma'am. My favorite country is India because I am Indian. I proud to be Indian and I love my family very much. My question is, why does Saturn have rings around it?
I'm sorry, why this?
My question is, why does Saturn have rings around it?
Why the
Why?
ring is surrounding? Why there
Oh,
is a ring?
why is there a ring? Uh, we think it's when Saturn formed in the early solar system. Perhaps there were moons there that shocked one against the other, and the particles formed the rings. The rings formed by gravity, the gravity around Saturn. So that is what we think. There are many interesting studies of rings that you can look up online, and even how there are some small moons within the rings, and some of them we call shepherds. Like they keep the rings in line. Let's say it's like a shepherd keeping sheep, aligned. And anyway, I like India very much too. I have only been once, and I hope to go back.
Sure.
I did not have a chance to go to the Taj Mahal yet.
Thank
Sure,
you.
sure. We will welcome
Thank
you
you,
at Taj
ma'am.
Mahal, and other than all the science related, space related establishment also. Uh, Ma'am, another, we are going to Arunachal Pradesh, very near eastern side of India, where the ever first when sun rises from there. Uh,
Oh,
so from
Good
there,
morning, ma'am.
Aryan Prasad from Itanagar. Introduce yourself and ask your question.
Good morning, ma'am. Good morning, sir.
Good.
Ma'am, am I audible?
Yes,
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 yes, you
yes.
are. Good morning to you. It's good evening for
uh,
me here, but
I'm Aryan Parasar, a student of Vivekananda Kendra Vidyalaya, Itanagar. And first of all, I would like to sincerely thank the organizers for giving me this opportunity to interact with you today. And I want to ask that we know that volcanoes often help us understand the past of a planet. So my question is that how do scientists in this field collect information, organize them, and study the volcanism of planets like Earth and Mars and the moon like the Io you talked about in your presentation? So could you please help me understand that?
sure. Yes. It's actually quite different depending whether it's Earth or the planets, because Earth, um, usually the first thing we do when we want to study a volcano is we go there. We collect samples, we analyze samples in the laboratory, we find the composition, and with other planets and moons, you can't do that easily because you can't go there. Well, we've been to the moon, but that's very, very expensive. The astronauts brought samples back from the moon, which and there were some collected by robotic spacecraft. And India has landed on the moon as well. So the moon is a little bit easier because you can get samples. But with other planets, it can be, and moons like so far away, like Io, it can be really quite difficult. So sending this spacecraft, we we can have we have instruments on the spacecraft depending where you're going. There is a whole process for the scientists, to put the best instruments, the ones that will answer the most science questions, on the spacecraft. But we use a lot of images, topography, spectrometers to try to understand the composition. And in the case of Io, we measured temperatures of the lavas. um, so you do the best you can without actually physically going there. um, and in fact, I remember a colleague of mine who studies volcanoes on Earth. I gave a lecture about Io at a conference, and I showed how we use temperatures to try to find the composition of the lava, because different types of lava melt at different temperatures. And afterwards, he came to me and he said, this is not very good because there can be variations in the composition. And why are you using temperature? And I had to explain to him that pretty much all we had, And he said, "Oh, yes, of course that's what you have." So you do the best you can with the instruments and the data you collect, and often the best analysis is when you put several instruments together, several different types of data. So when I was studying Io, I would always superimpose the spectrometer data on the images, for example. So I
Yes,
hope
ma'am.
that answered your
Yeah.
question. It's a very
Thank you, ma'am.
long answer. Okay.
Thank you, ma'am. Thank you. And another student from Jammu and Kashmir, Mehnu Riaz. It's a very beautiful place, ma'am, Jammu and Kashmir.
Yeah.
And from there, this student, and temperature is also very low there. But breaking all these barriers, she joined us. Mehnu Riaz, ask your question, introduce yourself.
Firstly, respected higher dignities, I wish you good morning. I'm Mahnoor Riaz, a space enthusiast from India, UT JNK, Kulgam, Kashmir. I'm thrilled to have this opportunity. I would like to begin by thanking organizers for the opportunity to ask question. My question concern that I would like to address is how do volcanic processes on other planets influence our understanding of habitability and the potential for life beyond Earth?
Yes, a very good question. Uh, because as I was saying when I was explaining about Enceladus and also Titan, um, three of the ingredients you need for life to form uh, uh, heat, water, and organic materials, carbon based materials. Um, Now, you might need other things, but those three we think are essentials. And we're trying, it's one of the biggest questions in planetary science. Did life exist elsewhere? And it's a very difficult one to answer, particularly with remote sensing. You can find organics, but finding life, it's very very difficult to do unless you bring a sample for us to analyze in the laboratory. But we don't entirely understand how life began on Earth. But if we found life on Mars, for example, and one of the rovers on Mars has it has very good instruments for actually looking at composition of rocks, and it found a particular rock that the scientists who work with that really think it could be a sign that life, probably doesn't exist now, but may have existed in the past. But we really need to bring that sample back to be studied in laboratories here. And unfortunately, there is a plan to do it, but it's a very expensive mission. So at the moment, it's not going ahead. But I hope that it will eventually.
Thank you very much, ma'am.
Thank you, Mahanur. And now one person from same Jammu and Kashmir, another one, Nidul Pandit for Army Public School, Damana, Jammu and Kashmir. Introduce yourself
Good,
and
mo-
ask the question.
Good morning, ma'am. Good morning, sir. I am Mridul Panta from class 5th from Army Public School, Damana, Jammu. I am thank you for your opportunity to talk with me.
You're welcome.
Here, here is what here is my question. What, what challenges does astronaut faces while living in space for a long period of time?
Okay. It's not something I specialize in because I don't work with the astronaut program, but I can tell you that a lot of the challenges are uh, physiological because the human body was not made to live in zero gravity. So my son is a doctor. He is a what we call a resident doctor. So he's in the final stages of his training, and he actually wants to be an astronaut. So he has looked into this much more, and there are all kinds of things that space does that are bad for the human body, particularly depending how long you stay. It's and We have sent astronauts to the space station for actually, many months uh, to study that. But there can be problems of your bones get weak, so astronauts have to exercise a lot, um, on bicycles and mm, whatever equipment they have, because you're on zero gravity, and your body's not designed for that. Your muscles get weak, then your bones get weak. There are problems with the eyes as well. There can be problems with a higher possibility for cancer. So it's actually very challenging. Now, if you send someone to the space station for couple months. If you send someone to the moon, like the Apollo astronauts, many of them live to a very old age. Buzz Aldrin walked on the moon and he's now 95. So it's, that's okay if it's a short period of time. If it's a long period of time, like sending humans to Mars, that's really going to be a challenge.
Thank
Thank
you,
you, ma'am.
madam. So many students are eagerly about this because Sunita Williams is there, and
Yes. Yeah.
recently she visited Delhi also. She have a lecture in the IIT Delhi. So many questions are raised during this moment. Now we are shifting to New Delhi. Uh, Avni Malhan from Birla Vidya Niketan, New Delhi. Please ask your question. Introduce yourself and ask your question.
Good morning, sir. Good morning, Rosalie ma'am. Ma'am, I am Avni from Birla Vidyaniketan, New Delhi. Ma'am, I am 14 years old, and my question is that, ma'am, you had shared that there is a presence of a global ocean on the Enceladus moon. Ma'am, if there is a presence of such a global ocean, can there be presence of volcanism and geological activity on these exoplanets? And if there is, how does that promote the possibility of life on these exoplanets?
Oh, yes. Okay. Exoplanets are planets outside our solar system. So, yes, there is a possibility that life could exist on exoplanets. I haven't really studied them directly, but because they're so would be so difficult to get to, take such a long time, the best possibility to detect a sign of life is to study the atmosphere and see if there are organic materials, for example, in the atmosphere. So there are many astronomers studying that. It's not quite my expertise. But there is no reason to think that we couldn't have moons like Enceladus or Io in the outside the solar system. In fact, I had a postdoc. I'm still collaborating with him. He is from an Indian family, but in the United States, and he, we published a paper that he led about the possibility of an exomoon, that is a moon around an exoplanet that is eventing sulfur like Io. So that could be like an exo Io. And it's very interesting work. Mm.
Thank you, ma'am.
Okay, ma'am,
Now I
thank
would
you so
like
much.
to invite.
Thank you to the organizers for giving me this opportunity. Thank you.
Thank you, Abni. And now I would like to invite Somalila Banerjee to ask from West Bengal, Kolkata, to ask your question.
So, good morning, sir, and good evening, ma'am. I am Shomala Banerjee from Adamus International School. First of all, I would like to express my heartfelt gratitude for giving me this opportunity to learn so much about science, especially in the fields of astronomy and volcano. And my question is, in the slides, you explained that whenever a spacecraft is released from Earth, it follows the slingshot maneuver. It follows a path which is not a straight line, but by following that, the kinetic energy of the spacecraft is more, the velocity is more. So why does it happen like that?
Oh, well, not sure I understand the question exactly, but um, it is you have to do a very careful calculation, which is not something I do, to fly the spacecraft just right around the planet. So the planet, like Venus, kind of pulls the spacecraft towards it because of the gravity. But if you do the maneuver just right, it will go around but not enter in orbit around Venus. You don't want that. It will come out with more energy and higher velocity. And in fact, I didn't have time to explain that, but this trajectory was invented because of the Galileo spacecraft. As I mentioned before, Galileo was supposed to be launched 2 years earlier on a shuttle immediately after Challenger. Challenger disaster happened, shuttle program shut down for a while, and we have what we call some windows of opportunity, like the if you launch from Earth to go to Jupiter, Galileo was supposed to go direct, but the planets have to align. So by delaying the launch, it couldn't go direct. And then also the shuttle program started having many more safety requirements. And so Galileo was released from the shuttle, but it needed a rocket, in it to send it to Jupiter. Well, because of the new safety regulations, it had to have a smaller rocket. So our trajectory engineers realized that it couldn't get to Jupiter. And it was, I mean, this was long before I joined JPL, but I heard the stories. And they even considered sending the spacecraft to the Smithsonian Museum because it couldn't get to Jupiter. And then one of the trajectory engineers had this idea, and the story goes that he woke up during the night and and he said, "It's Venus, it's Venus." And his wife was kind of puzzled, but that's the idea he had, and he woke up from his sleep that if we launch the wrong way towards the sun rather than towards Jupiter, we could do this maneuver around Venus. And that's what saved the mission. And then after that, several other missions like Cassini, use this kind of trajectory.
Thank you
Thank
so
you,
much,
ma'am.
ma'am.
Thank you, Somalia. And now I would like to invite Reshma Dipsi from Andhra Pradesh. Reshma, unmute yourself.
Yes, sir. Good morning, sir. Good morning, ma'am. Myself, Reshma Adibasi of grade 11 from Shri Bharat Vidyashram School, Puducherry, ma'am. And my question is, where does the particle goes inside the black hole, ma'am?
Oh, well, that's a very complicated answer, and it's not something I specialize in. But a black hole essentially has such enormous gravity that it just attracts everything, and nothing can escape from it, even light. So that's why it's called a black hole. And there are several theories of how black holes form, it depends on the size of the initial star. They start out as stars, and then they use all the fuel, and they eventually like collapse onto themselves, and it's such strong collapse and gravity, they become so dense that then not even light can escape from them. But I recommend that you look for some online resources on black holes. There are many with animations and animation movies that people make to explain them, because it's not really my expertise. I mean, I studied them many years ago when I was an undergraduate, and a lot has changed since then of our understanding. Okay.
Thank you,
Okay,
ma'am.
ma'am. Thank you,
Thank
ma'am.
you, Reshma. And another question from Arush from Rajasthan. Yes, unmute yourself. Unmute yourself. Hmm.
Uh-oh. You're still
You
muted.
are not audible. Unmute yourself. I think you your device is not.
If you can access the chat, you can also write
Yeah.
the question in the chat.
Yes. You please write down the question in chat box. He is from Mahatma Gandhi Government School, Rajasthan, Arush. Please write down in chat box. We will take the question. Some questions are also in our YouTube from our YouTube viewers. One of them has asking that which planet will be nice to survive human beings except Earth.
Which planets it would be the best for human beings to survive? Is that the question?
Except
Uh,
Earth.
except Earth, yes. Um, well, there is nowhere that we know of where human beings can survive without a lot of special environment, equipment. Um, of the other planets, Mars is the most likely, but we would have to get a lot of um, materials there. Of course, you can't breathe the air, but at least it has, um, some. It's not as much gravity as the Earth, but it has some more than the Moon. And the length of the day is similar. So I think that in the future we'll probably have stations on Mars. But the moon is the easiest because you can go to the moon and come back in a short time. And there are plans now to build like bases on the moon. Um, it's and In fact, the NASA administrator came to visit us today and talked about that we'll go back to the moon and stay. Uh, and that means that we're going to construct habitats for humans. And if you think about it, you can't live in Antarctica if you don't have protection. So when I went to Antarctica, I mean, we thought it was very similar to what a moon base or a Mars base would be in the future because you had this environment outside that was trying to kill you. So needed specialized clothing and you needed door locks, that would not let much material going from the outside to the inside, and so on. I see a question in the chat. Discovering 71 active volcanoes set a record. What surprised you most compared to Earth? Well, what surprised us most is that we made some observations of the temperature of lavas. And, as I said, it's not a perfect method to tell composition. But what it seems to be the case is that some lavas are very, very hot, too hot to be basalt, which these days is the hottest lavas on Earth. So maybe they are what we call ultramafic, and those are lavas that erupted on Earth hundreds of millions to billions of years ago, very primitive lavas, and they're much hotter. But we need a sample to really find out for sure. Okay, and I
Ma'am,
see.
one more question.
Yeah.
Uranus is cooler than Neptune despite being nearer to Sun.
Uh,
He wants to know why.
oh yeah. Well, I am not sure about the answer to that. It's not something I have studied at all, but there are many factors, like the atmosphere that and depends where it's cooler, where you're measuring the temperature. Is it the top of the atmosphere? Or, we can't measure until we send a probe. We can't measure the temperature of the interior.
One
I
more question.
Yeah.
One more question. How Jupiter's moon satellite volcanoes different from Earth's volcanoes?
Hang on. Can I read how Jupiter's
Jupiter's moon
satellite?
satellite
Yeah,
volcanoes
is different from Earth's
different.
volcanoes. Well, for a start, the answer that I just gave, the lavas may be of the type that no longer erupt on Earth, because they seem to be very hot from what we can measure. So maybe they are like volcanoes on Earth, hundreds of millions to billions of years old. And and something else is that we have very, very long lava flows, very big calderas. Some of the lava flows are similar to what we call flood basalts on Earth. And in fact, in India, you had the Deccan traps, as they are known. They are very, very vast regions covered by lava flows. Maybe it's, and I'm sure there are many other differences, but those are just two. And I just remembered something about the Uranus questions, is that Uranus does not have an internal heat source, as powerful as what Neptune has, because it depends on several factors, but also the size of of the planet. But it has to do, from what I remember, with internal heat. And it also has a funny tilt of its axis, and that may have an effect as well. Atmospheric composition has an effect, and even how much sunlight it can reflect also has an effect. Okay, well, that's a lot of questions.
Lot of question, ma'am. Thanks for being with us. Lastly, we have our Bugle Jain sir from Rajasthan Kota.
Yeah.
Jain sir. Hello. We have one teacher also, Shakshi Barma ma'am.
Okay.
We have Bugle Jain sir from Rajasthan Kota. You would like to unmute yourself, sir? Unmute yourself. You would like to...
Okay, sir. Okay, sir. It's a very proud moment, very proud moment. I, Bigul Jain, first of all, would like to convey my thanks to the organization to giving me wonderful opportunity. Credit goes to Anjan Banik ji of Dasa, Tripura, India. Credit also goes to our government, that is Government of India, who is doing a lot of development of science, scientific temperament for benefiting the vision for Viksit Bharat. A big salute to Rosaly Lopes, the Brazilian woman who had worked for 3 decades at NASA. We Indians know Brazil for football player Pele, for good quality coffee, Brazilian carnivals, natural beauty, but from last 3 decades, Brazilian known or Rosalian Lopes, a big salute. Really, you are a wonderful woman, and we all invite you, India, for beautiful journey. Thank you. Thanks a lot. And in last, we ask some question. You hear the name of Yuri Gagarin in the age of 4 years and transform your life for astronaut. How would become possible?
To I'm sorry about astronaut. I couldn't quite hear it all.
Sir, repeat your question, sir. Sir, repeat your question, sir.
Only one question.
Sir, repeat your question, sir.
Hmm. Yes,
Once
yes.
again, you just ask the
You,
question.
you hear the name of Yuri Gagarin in the age of 4 years and transform your life for astronaut. How it becomes possible? Because it is a very, very long journey, madam.
Yes,
Very
yes,
long journey.
I did. I knew that becoming an astronaut is still my dream, but it is very difficult to become an astronaut. For a start, I had very bad vision, with myopia. So I knew that was unlikely. It wouldn't make me a good astronaut candidate because they want people who don't need glasses or contact lenses, and also the requirements to apply for NASA. I had to be a U.S. citizen. Well, by the time I became a U.S. citizen, and had surgery to correct my vision. I was then considered too old, so who knows? Maybe one day as a commercial astronaut. It's many people are flying now commercially, because companies are can send people. Even our NASA administrator, new one, Jared Isaacman, he was a commercial astronaut. So it's always possible. I think we always have to try to keep our dreams alive. And I see several questions in the chat, but it's starting to get pretty late for me. So I'm going to try to answer quickly, if that's all right. How do tidal forces driving Io's extreme volcanism differ from potential cryovolcanic processes on Titan? And what might future missions reveal about Titan's habitability? Yeah, well, the tidal forces on Io are much stronger than on Enceladus, but essentially is the tidal heating that is enabling volcanism or cryovolcanism in the small bodies. Yes, there is a mission going to Titan called Dragonfly. It's like a drone and is going to land and make a lot of chemical measurements. So we're going to learn a lot from that mission that various friends of mine are on. And how does space research help solve problems like energy or water scarcity on Earth? Well, the studying geology of other planets, for example, helps us understand the geology on Earth. Studying volcanoes on other planets help us to understand volcanoes on Earth. And because on Earth you only have a very limited set of physical parameters. So if you're really trying to make models of how volcanoes work, for example, it really helps you a lot to test this model. Say, well, but what if the gravity is different? What if the atmosphere is different? And the atmospheric pressure, how does all that come together? And I'm going to give the example that I think is the best about how studying other planets can help us on the Earth. when astronomers were looking at the moon, that was before the Apollo program, before astronauts went to the moon. Um, they were looking at the moon through telescopes, and they saw a lot of craters, and they thought that these craters were all volcanic, because on Earth you look at these craters and they were formed by volcanoes. Well, uh, eventually, we understood that these craters were not formed by volcanoes. The vast majority of craters were formed by impact from comets, from asteroids, big meteorites. And we understood that if they made lots of impact over there, they can come here too. And then we started studying craters on Earth, and chemical compositions that there are things like that really show that there was a shock. So the first crater to be studied was Meteor Crater in Arizona, that some people thought might have been caused by a meteorite, but that was even a bit of a crazy idea in the 1950s, 60s. And then we started realizing that this is a real danger for the Earth. And now we have spacecraft observing asteroids. We have many telescopes that have, and a whole program is actually international, called Planetary Defense. And if we see an asteroid coming towards Earth, we can do something about it. But if we hadn't studied these other craters, if we hadn't found out that these craters on the moon were impact, we might not have realized that. So I think that's a really good example. Oh dear, more questions. I am sorry that it's getting late over here, but uh,
Yes, ma'am.
yes, I am studying IO with Juno as well. I didn't have time to put in slides about Juno, but yes.
Thank you, ma'am. Thank you for being with us. Thank you. Arush, have you any question? Arush from Mahatma Gandhi Government School, Rajasthan. Have you any question?
You're
No,
muted.
you are not audible. Sorry. We are Devendra Kumar ji, have you any question, sir? Devendra Kumar ji.
Namaskar, ma'am. Good evening from India. Uh, I am Devendra Kumar from UPS Vadgaon. Here is astronomy lab, and I want to ask a question. How it is possible
Yes.
to create a
The last.
habitable zone on Moon and Mars planet?
Could you repeat the question? I'm having
Please repeat the
trouble.
question, sir.
I have
Come
a
closer, sir.
question. I have a question. Is it possible to create a habitable zone on Moon and Mars planet?
Well, oh, I see. Yeah, I think you're not talking about like a base, a building. You're talking about what we call terraforming, or making a planet habitable. People have talked about that for Mars, but it's very, very difficult. Uh, what you can do, as I said, on the moon, you can build a building or a series of buildings where inside you keep the conditions habitable, and then you go outside with your spacesuit. But that, yeah, it's going to take time. People are thinking about it, they're planning it, but it will take time and it will take money. No doubt about that. Okay.
Thank you. Thank you. Thank you.
Now, thank you so
Thank
much
you.
for having me. It's been a pleasure talking to all of you. I have only been to India once, and it was a very quick trip. Actually, I was giving a talk at the technical, the Indian Technical Institute in Varanasi. Yeah, that was very nice. But I do hope to go back. Okay.
Sure, ma'am. Thank you. It's our we are also feeling honored when we are taking lessons from you, ma'am. So it will be a great journey of in terms of getting knowledge about volcanoes, about the planets, exoplanets from your side. Thank you. Please keep your blessings and cooperation from your side to us for a long time, for a long duration in future also, so that our students may got encouraged and get motivation from you. Get you are a being a woman scientist, I think you are an inspiration for all of us, even for throughout the globe also. So thank you once again. Thank you for being with us. Namaskar.
Thank you so much. Thank you. Bye
Thank you,
bye.
ma'am. Thank you. So with these words, we are concluding our webinar, Vikram Sarabhai lecture series for this evening. We are also serving the certificate of participation through this event, for this event, and that will be available on WhatsApp group. So please join our WhatsApp group. It will be link has been given in description box as well as on screen also, even in chat box also. So join that one and collect your certificate of participation, which has been signed herself by Professor Dr. Rosaly Lopes, Deputy Director of Planetary Section of JPL, Jet Propulsion Laboratory, NASA, as well as a senior research scientist and volcanologist also. So with these words, I would also like to invite all the students to join and participate our event, that is India International Sarabhai Student Scientist Award for this year, which will be available and will be open every Sunday. You have to attempt a set of questions once within the period of 28 February. That is by Sunday, it is calculated by 22nd February. This is the last Sunday by February, if not extended, date extended. So, and link of Google form has been given in the description box. We'll start it from this Sunday, and every Sunday at 10 a.m. IST, you have to collect your password, and through this, using this password, you have to register. Along with that registration, you have to appear in exam also, and scorer of 80% scorer will be automatically granted for the next phase, or for the rest merit list will be there. So have a great day, and happy Republic Day also. So we are just viewing the this year Sarabhai Student Scientist event. Along with Sarabhai Student Scientist Award, we are also declaring this year that India International Sarabhai Teacher Scientist Award also. And whenever the student will fill the form, student will nominate one teacher, science teacher or mathematics teacher, as a mentor, and we will get the nomination for this award from the teachers through students only. So I would like to invite teachers also, so that student can fill this nomination form in a proper way, as well as appear in the registration along with examination for the India International Sarabhai Student Scientist Award. So with these words, once again, Happy Republic Day, 78th Republic Day, which will be celebrated tomorrow. And we are ending our event here. Jai Hind, Jai Vigyan.